In this particular module, we will take a look at forecasting temperatures. Recall that you have to forecast temperatures for 12Z and 18Z on your forecast. If you're in the Central Standard Time, 12Z will refer to 6 a.m. 12Z will refer to 6 a.m. and 18Z will refer to noon. So let's go ahead and take a look at how one might forecast for temperatures. If we go down to the weather links, and from there we can click on weather links galore. And since we are forecasting for surface temperatures, I need to look at sites in terms of surface. And so one of the first sites I'll look at is the University of Illinois. Feel free to look at any of these sites, but Illinois has the ability to animate, and also their graphics are pretty nice to look at. So let's go ahead and take a look at temperature. Now, what you're about to see here is a temperature of 2Z on January 11th, which is the evening of January 10th. And you see all of these colors here corresponding to temperature. The colder or the violet colors correspond to colder temperatures. The green correspond to warmer temperatures, and in between you have gradients of blue all the way down to the violet colors. Now, you'll also notice lines on here. These are lines of constant temperature or equal temperatures. In other words, I'm tracing out the 45-degree line, and these lines are what we call isotherms, lines of equal temperature. That's the definition for you, isotherms, lines of equal temperature. Notice that temperatures change rather rapidly over Florida. Down near Miami you have 70, then 60, and then 50 about halfway up into Florida, and then 45, 40, and then by the time you get into Georgia it's 35. Now if you look over Iowa, at 2Z, you'll notice the temperature is 40 degrees. As we sit here at 9 o'clock local time, we see the temperature here is 40 degrees. And then 45 just along the Missouri-Iowa border. So we have an area of warmer temperatures poking into Iowa. Now, what's going to happen? Are we going to have this cold air move down into Iowa, or is the warm air going to win out? One of the things that we can do is we can animate. Now let's go ahead and animate the last 16 hours. Because one of the things that I want to forecast for is 12Z temperature for tomorrow morning. Now one place I could start is to take a look at the 12Z temperature for the current day. What was the temperature this morning at 12Z? That might be a good first place to start out in terms of predicting temperatures. It's what we call persistence forecasting. What happened yesterday, we assume will persist into the next day and maybe the next. Now this certainly is not the best way to forecast, but it is a first way to forecast. And you'll see 12Z Wednesday, the current day, we had a temperature between 20 and 25 in Des Moines. Actually, Des Moines is about right where the cursor's at. So the morning temperature was 24 in Des Moines. So our first guess for the 12Z temperature tomorrow is 24. So we'll record 24 as our first guess, our first educated guess in that. Let's go ahead and see how temperatures changed through the morning up to 18Z. Now you'll notice at 18Z, the temperature over Des Moines was probably right around 40 degrees, 40, 41, because our 45-degree isotherm was in southwest Iowa. The 40-degree isotherm was located in central Iowa. So Des Moines was about 41 degrees. So we warmed up quite a bit from 24 at 12Z to 41 at 18Z. So if you were to assume that this same pattern will persist into tomorrow, that might be what you forecast your 12Z and 18Z temperatures for. Well, let's just go ahead and animate this. And we'll see as we go from 21, 22, 23 on up, temperatures begin to warm this morning. We see temperatures warming as we go through the day into Iowa, and the cold air staying at bay up in Canada. However, notice the last few frames, the cold air begins to move into Montana. Now watch this. So we go through the day, and now the colder air beginning to move southward. This is where our next system's coming through. Anytime you see these isotherms banding together, the way they're banding together up in Montana is indicative of a front, what we would call a cold front. This cold air will begin to move. Now, another way that we can forecast temperatures, specifically 12Z temperatures, is to look at what we call dew point temperatures. We'll define dew point temperatures a little bit later. But one thing you should probably write down is that the actual air temperature can never go below the dew point temperature. Again, the air temperature can never go below the dew point temperature. The air temperature can drop to the dew point temperature, but will not go below that. And the reason for that is if the air cools any further below the dew point, it will actually produce condensation. Recall from last week's lecture, condensation releases latent heat in the form of sensible heat, something that you can measure, thus warming the air. So it might be a good idea for us to take a look at dew point temperatures. And at 2Z, now recall we're forecasting for 10 hours from now. Okay, 10 hours from now, we're forecasting. For 12Z, we see that currently the dew point in Des Moines is somewhere between 25 and 30. This is a 30-degree isodrosotherm. Yes, I said isodrosotherm. That means lines of equal dew point temperatures. Lines of equal temperatures are isotherms. Lines of equal dew point temperatures are isodrosotherms. So currently the dew point is between 25 and 30. We'll call it about 27 in Des Moines, Iowa. So let's take a look at the 12Z temperature this morning. And so we'll need to animate, and we'll take the last 16 hours. And again, we're going to use persistence forecasting, assuming what happened this morning at 12Z will be the same thing that happens at 12Z tomorrow. And as long as we don't have any cold fronts or warm fronts coming through, or unless we have cloud cover, then we can use this particular type of forecasting. Okay, let's take a look at 12Z. At 12Z this morning, the dew point was 15, somewhere between 15 and 20. So the dew point was right around 17. Recall, however, our air temperature was 24. So the actual air temperature did not fall to the dew point temperature. There was about a 7-degree spread there. So if we're doing persistence forecasting, we could assume that there would be about a 7-degree spread between the dew point temperature and the air temperature. Let's go ahead and animate this and see how dew point changes as we go through the day. Notice the time changing up here at noon. Dew points are in the 20s. Now notice this large area of 30-degree dew points moving up. Recall from the first lecture I said that dew point temperatures are an indication of moisture. So we're beginning to move moisture up into Iowa. And in fact, we get 30-degree dew point temperatures here in Iowa. So if dew point temperatures are increasing, and I said the air temperature can never fall below the dew point, then our forecasted temperature will be between 25 and 30. So instead of 24, which was our original, which was actually our low temperature for today, we may want to raise it a few degrees, maybe right around 30 degrees for a low, based upon the dew point temperature. So that gives you an idea on how to forecast for 12Z temperatures. What about 18Z temperatures? let's go back to our temperature contours. And if we look at the last 12 hours, and let's go to 18Z. At 18Z today, the temperature was right about 40 degrees. There's the 40-degree isotherm line. So if we use persistence forecasting, we would say the temperature will be about 40 degrees tomorrow. Again, unless there's cloud cover, which would lower the temperature, and unless we had the passage of a cold front. But that cold air seems to be hanging back up into Canada. It's just beginning to nose down into Montana. Should be here within the next day and a half. But probably the temperature right around 40, 41 degrees might not be a bad forecast. So this first module on temperature forecasting is in terms of persistence. In other words, what happened yesterday, what happened today, and the next day. We also use dew point temperatures to forecast for the minimum at 12Z. Now, we have used the possibility of persistence to forecast our 12Z temperature, and most notably, we've looked at dew points for our minimum temperature at 12Z. If we're to use the dew points, we would forecast temperature to be about 30. But what I'd like you to do is to notice the animation there of surface temperatures. It begins at 15Z today and runs all the way through 2Z, which is this evening. And notice our 30-degree temperatures. Let me go ahead and slow this down here, or stop it. If I go to the latest one, which is 2Z, we'll see that 30-degree temperatures are up into central Minnesota. And in fact, if we go back a couple of frames, we see those 30s are not really getting very close to Iowa at all. In fact, what we're seeing is temperatures staying pretty steady. So again, let me just go forward in time. We're seeing a little bit of cooling, but as of 2Z, the temperature in Des Moines is still 41. So do we want to go all the way down to 30? I'm thinking probably not. And in fact, temperatures have not changed very much over the last few hours. In other words, that cold air sitting up over Minnesota, up in that area, is staying in that area. In fact, the cold air over, or the warm air over Iowa seems to be winning out. And so I am going to want to increase my minimum temperature a little bit, from 30 probably to about 38, 39 degrees. Because again, the 40-degree isotherm is still sitting over Iowa, and it has not moved very much. Again, let me go back a few hours. Again, notice back at 23Z we were at 45. And over the last few hours we've decreased to about 40, 41, 42, which is only about a 3-degree drop in temperatures over the last few hours. So I'm thinking probably somewhere in the neighborhood of 37, 38. So persistence forecasting and dew point forecasting for this particular situation is not going to be that effective, because we have warmer air moving into the area, a warm front. And so that will change things a little bit. So as you can see, it's a rather complicated process. I mean, there are a lot of factors. I guess I should say it's not that complicated of a process, but there are a lot of factors to look at that influence the weather. And initially, beginning to learn how to forecast can be quite daunting. But as you get more practice and begin to get more rules of thumb under your belt and to begin to build your forecasting skills, this will get easier as you go through the semester. I hope you've enjoyed this particular module on forecasting for temperatures.